So differentiation, going to be differentiating from first principles. So hit pause, copy the lesson objective down. Once you're done, hit play again. So in order to find the gradient of this curve, our curve here, y equals f of x, what we do is we take 2 points on the curve, have this first one here, which is we're going to call xy, or x and f of x. I think you know why I'm calling it f of x, because you guys have differentiated before from first principles. And we need a second point then on the curve, which we are going to call, well, there's a change of delta x from the first one, so an increase of delta x. So that's going to be x plus delta x, and f of x plus delta x. Oops, forgot the brackets there, and the square brackets. Those are our 2 points. Okay, and now we're going to look at the change in y. So the change in y, the vertical height there, that's going to be f of x plus delta x. Minus f of x. I think you can see why we've used that now. And the change in x is going to be x plus delta x minus x, which leaves us with just delta x. So let's write our gradient here. Gradient is given by the change in y over the change in x, dy over dx. That's going to be equal to f of x plus delta x minus f of x, all divided by the change in x, which is delta x. Now those are 2 points on the graph. In order to find the gradient at a point on the graph, we have to go to the limit as delta x tends to 0. So we write dy over dx is equal to the limit as delta x tends to 0. So a very, very, very small, tiny portion of the curve, and f of x plus delta x minus f of x, all divided by delta x. And this expression we're going to use to differentiate. So hit pause, copy the curve down, and copy the expression. Once you're done, hit play again. I'm going to look at differentiating x squared. Okay, so here's my curve, y equals x squared, and I want to differentiate x squared. I'm pretty sure some of you remember, if you differentiate x squared, you should be getting 2x. Let's see if that's provable. So I have my 2 points on the curve, which this first one here is x and f of x, which is x squared, so x squared. I've got my second point, which is just delta x away, and that's x plus delta x and x plus delta x squared, which is the f of x plus delta x squared portion. Change in y and change in x. So change in x delta x, change in y, x plus delta x squared minus x squared. So got my expression dy over dx, which is equal to the limit as delta x tends to 0 of f of x plus delta x minus f of x, all divided by delta x. Our function y is equal to x squared, so we can write the limit as delta x tends to 0 of our function, so that's x plus delta x. This is squared minus x squared, all divided by delta x. So that's equal to the limit. We always write the limit. Don't forget that. X, and we expand the brackets then. X squared plus 2x delta x plus delta x squared minus x squared all over delta x, which is equal to the limit delta x tends to 0 of, now the x squareds cancel out. We've got x squared minus x squared, so they cancel each other out, and we're left with 2x delta x minus delta x squared, all divided by delta x. Well, two ways of doing this. We could split them up just to show. I tend to just cancel. Delta x cancels with 1 delta x here and 1 here. But as this is the first time, let's just show that. So we've got 2x delta x over delta x minus delta x squared over delta x. If we put square brackets around them, it's going to be equal to, well, we can cancel. Delta x cancels with delta x there, and the delta x on the bottom cancels with one of the delta x's on the top. So we're left with the limit, oops, didn't change to red then. Limit as delta x tends to 0 of 2x. There should be a plus there, sorry, plus delta x. And as delta x tends to 0, that becomes 0, so dy over dx, we're left with 2x, which is the derivative of x squared. So hit pause, make your notes, and it's handy to sketch the curve. It's not absolutely necessary, but it is handy to have it. Once you're done, hit play again, and then we'll look at another example. Okay, so if y equals x squared, then dy over dx is equal to 2x. So example for us, find the gradient of the curve y equals x squared at the coordinate 3, 9. Well, dy over dx is equal to 2x. At the point 3, 9, x is equal to 3, so dy over dx is equal to 2 times 3, which is 6. That's our point there. Hit pause, make some notes. When you're ready, hit play again. So, another example. It's a point with coordinates 4, 16 lies on the curved equation y equals x squared. At the point A on the curve, the curve has gradient g. Show that g is equal to the limit as delta x tends to 0 of 8 plus delta x, and then deduce the value of g. Well, we can differentiate from first principles. We've got our expression dy over dx is equal to the limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x. Our equation is x squared, so it's equal to the limit as delta x tends to 0, f of x is x squared, so we've got x plus delta x squared minus x squared all over delta x. Now, at the coordinates, we can sub for x in our formula. So dy over dx, or g, the gradient, is equal to the limit delta x tends to 0 of x is 4, so we've got 4 plus delta x squared minus 4 squared all over delta x, which is equal to the limit delta x tends to 0 of 16 plus, we expand, 8 delta x plus delta x squared minus 16. Very similar to what we just did, except we've got a number now over delta x. The 16's cancel, just change color. 16 minus 16 is 0, so we're left with, always write the limit, delta x tends to 0 of 8 delta x plus delta x squared all divided by delta x. And we can cancel our delta x's. So the delta x there cancels with, the one on the bottom cancels with one up there and one here. And so we're left with, back to red, delta x tends to 0 of 8 plus delta x, which is the solution for part A. So that's part A done. And then part B says find the value of g. Well, we take the limit. As delta x tends to 0, dy over dx, or g, is equal to, that goes to 0, so we're left with 8. So g equals 8, and we prove that. So hit pause, copy the notes down, and I've got some questions for you. Okay, so I've got these 5 questions for you for classwork. So differentiate from first principles. If you finish that, then some additional questions in 12b, and some extra questions for you in 12b. If you finish those 5, those 5 are enough. Okay, good.